Hello and welcome everyone. My name is Mattson and I'm an Extension Support Specialist here at the GLASE Consortium. Today you're going to be hearing the first video in a series focused on greenhouse energy and carbon benchmarking. But before we get started, I want to very briefly introduce you to the GLASE Consortium. So we are the Greenhouse Lighting and Systems Engineering Consortium out of Cornell University, and we're here to transform greenhouse lighting and systems management to support climate smart CEA. Now, we do so by conducting research and educating growers so that hopefully emerging technologies can be adopted faster and help growers save money and ultimately reduce the environmental impact of energy use in greenhouses. What we have here on this slide are a few of the three main ways that we support the CEA industry as well as our GLASE members. And so, as I mentioned, GLASE conducts a variety of research projects, which are focused on greenhouses, but also include indoor agriculture. And ultimately, we hope to seek to facilitate technology transfer by showcasing those results on plant growth. We also provide a variety of webinars, technical articles, short courses, and other educational resources and workforce development programs to help support the CEA industry. And finally, our membership values our networking initiatives. And so some of those include things like our quarterly industry advisory board member meetings, our online networking platforms, as well as the annual in-person GLASE Summit. I do want to take a moment and highlight a new GLASE initiative, which is a platform called the GLASE Library. We've very recently launched this platform, which is a central place where our members can access past webinars and other resources, including all of our previous short courses, are available to view on demand for GLASE members. And so we hope that you'll scan that QR code or bookmark that link and check it out. Our members are very valued, and we hope that you'll consider joining GLASE as either an individual or as an organization. And I'm happy to connect and share more information about what that might look like. We have a variety of membership levels and packages to suit your interests and needs. So please feel free to contact our team to learn more about GLASE membership. Lastly, I want to very briefly just highlight another initiative called Vivid Canopy. This is a networking platform that's launched by GLASE, where folks working in the CEA industry can connect, and organizations can showcase how they're leading by example in hiring a more diverse workforce. So we hope that you'll join our LinkedIn group and get connected. So with all that being said, I want to thank you for taking a moment to learn about GLASE. And now you'll be hearing from our GLASE Executive Director, Gretchen Schimelpfenig, as well as our Principal Investigator, Dr. Neil Mattson, who will be presenting the first video in this series called Understanding Greenhouse Energy Use. Thanks so much and enjoy.
Thanks, Matt, for the introduction. And so now we're going to dive in together. I'm Gretchen Schimelpfenig, Executive Director of GLASE, and joining me is Dr. Neil Mattson, one of our greatest principal investigators who founded GLASE. And Neil, why don't you give a quick introduction? We're going to have seen some information about us before, but I just wanted to let folks know, why should we trust you to tell us about greenhouse energy and benchmarking and so on?
Thanks, Gretchen. I'm a professor in plant science at Cornell University. I'm a horticulturalist and I direct our controlled environment agriculture program. So I've been here for 17 years. I also work as a statewide greenhouse extension specialist in New York State. So I've visited hundreds of greenhouses and helped guide conversations surrounding adoption of energy efficient practices.
Great. So working with real commercial businesses, that's what we have done. And what we've also done is research these things in our academic environments too. So let's talk about both today. The first section of this presentation is on how do you understand greenhouse energy use? So some context. Maybe not all of us are in touch with the energy goals or policies at the state or maybe federal levels in our various countries where we live. But for some context, it might be helpful to understand why are there maybe other levers being pulled to encourage greenhouse growers to reduce the amount of energy that they use. Well, there are state level goals in some places, and we're going to use New York and Connecticut as two examples close to home. But these are policies that may influence different things like programs offered to growers, as well as maybe other things like requirements or codes made about how greenhouses can be constructed. So here's some examples for New York. You can see that our goal in New York is to reduce greenhouse gas emissions by 40% from 1990 levels, and we're not yet there, but we've got a few more years, and you can see that those goals get more aggressive for 2050. And we're focused on some four major contributors to greenhouse gas emissions. That includes transportation. We all still are generally driving fossil fuel cars, but even that, where there are other things like 18-wheelers and ships and other things that are still being used for fossil fuel. And then if we're talking about greenhouses, though, those are generally going to be things that are contributing to things like the commercial buildings, greenhouse gas emissions, or maybe things from electric power. For Connecticut, to compare, they also have some similar goals around 45%, comparing to a different baseline, but then in 2050, kind of ratcheting up to a higher reduction of greenhouse gas emissions. And they similarly have some contributions to greenhouse gas emissions that are focused on transportation. That's why you might see a lot of electrification of vehicles. But then looking at commercial building, heating electrification or heating efficiency is also going to be a focus for people in the northeast of the US, as that is a major contributor to our environmental impact. So
And
relating
Gretchen,
this to, go ahead, Neil.
Gretchen, a semantics question. Do you prefer the term carbon equivalent emissions or greenhouse gas emissions? I feel sad that we call them greenhouse gas emissions because it's referring to the greenhouse effect that the atmosphere traps
Thanks for
more
bringing that
heat,
up,
kind of
Neil.
like a greenhouse. Yeah.
Yeah, we're not talking about greenhouses themselves when we're talking about greenhouse gas emissions. And so we'll talk about units of greenhouse gas emissions
Mm.
measurement in a little bit. And that can be measured by CO2 equivalence, which is sort of like gathering up a lot of other greenhouse gas emissions that affect the environment, like methane, and making them equivalent to
Mm.
CO2. And
Hmm.
so I don't love the term carbon emissions because it's not actually carbon, it's CO2. But
Right,
I think
right. We have
that I
methane
think
and
that
nitrous oxide and all those
yeah,
other
and other
ones then.
things
Yeah.
like that.
Hmm.
So it's a matter of understanding. And if it's something that everyone can understand, I think if carbon emissions is easiest for everyone to understand, then let's keep calling it that, because that's what folks can relate to.
Cool, cool.
But let's not blame the greenhouses, right? They're not generally
Exactly,
the
exactly.
major
Yeah.
reason why these emissions are happening. So
Hmm.
next slide. Let's talk about the greenhouses, though. So energy use in greenhouses is not as similar to indoor farms as one might think. They have very different building construction. And so, Neil, why don't you tell me what you've seen in the field? This is a resource from the University of Connecticut, so this isn't just us saying what annual energy use of these systems is, but Neil, what have you seen in the field?
Yeah, so it really depends on the type of operation, of course, which might be a common theme here. The majority of greenhouses in New York and New England tend to be growing floriculture plants, which have less need for supplemental light, but they do need heat to keep them alive and growing during the winter months. And so I think this data would come from those type of operations where 70 to 80% of their energy use is from heat. 10 to 15% is electricity. A lot of that would be the fans that circulate air and cool the greenhouse, and irrigation pumps and so on. And and then truck and tractor equipment to still move things around in an operation is about 5 to 10%. If you are using supplemental light in the wintertime, then I think these numbers would change a fair bit. And I don't have maybe an exact percentage, but I would say heat and electricity are closer to equal to each other in that case. And then truck and tractor is still there as well.
Yeah. So the picture on the right here is of a unit heater in a floriculture greenhouse. There might be various different types of heating systems used in greenhouses. We'll talk more about those in a bit. But yeah, Neil's point is that energy in greenhouses, the balance of that, whether it's electricity, natural gas, maybe other fuels like propane or fuel oil, kerosene, the balance of that is really dependent on where you are, how much heat you need to do, and then how much supplemental lighting you're going to use for the crop you're growing.
And I get this question from growers quite a bit, where they'll say, well, why does my greenhouse cost so much to heat? And it's because greenhouses, their goal is to try to let in as much sunlight as possible. But what that means is that the materials that cover a greenhouse are not very good at providing that insulative value. And so some of the common greenhouse materials that we use are like single layer or double layer of polyethylene plastic, glass, double polycarbonate, and so on. And so the light transmissivity of single layer materials is about 90%. We do have to add in the structural components that can also shade a greenhouse. So in reality, about 50 to 70% of sunlight gets into a greenhouse, but through that single layer of glass or plastic itself, about 90% gets through. So, however, its insulative value then is about 20 times less than a house that has fiberglass insulation. So the way that I think about that is if I have a 2,000 square foot house that I have fully insulated, and a 2,000 square foot greenhouse, it could cost me 20 times more to heat that greenhouse during the winter time than it would to heat my house. And then that also tells us something about what we could do with energy efficiency in a greenhouse. So one of the things that we can do is surface areas that we don't need to let light in, like the knee walls all around a greenhouse. Those would ideally be insulated so that we reduce the surface area for heat loss. Some operations will also insulate their north wall if it doesn't mess up light uniformity too much, for example.
And I'll mention here that some codes and standards are starting to address greenhouse glazing materials. You may see in the International Energy Code, there's reference to different U values, which is the inverse of R value. U values being required for greenhouse coverings unless they're considered a low energy greenhouse. So I've actually encountered a couple of greenhouses constructed in are being constructed in 2025 that are encountering these codes, and it really all depends on how it's enforced at sometimes the county level. So if you're planning on building a greenhouse, talk to your greenhouse manufacturer and the folks who are going to be approving the construction permits. And it may not be possible to build with single layer glass in the future in certain places. For example, in California, there's currently a code requirement that requires 2 layers of glazing, and you're not going to build a double layer glass greenhouse. It would probably be too expensive. But you might do a double layer polycarbonate or double layer polyethylene. So just a comment there about how you may want the highest light transmission, but consider how regulations in your area might affect your choice.
So, and something that I think growers think about intuitively is like which months of the year am I operating my greenhouse? Is it year round? Is it seasonal? And then the coldest winter months are when we need more heat. So heating degree days look at the difference between the average outdoor temperature in a month and heating to 65 degrees Fahrenheit in this case. And so maybe not unexpected if we're in upstate New York, December, January, and February are the months that have our highest heating degree days and hence our highest heating bills. And then March is still quite a heating degree day month, and then by the time we get to April, it gets a lot cheaper to heat a greenhouse. Some growers will actually use a little bit of heat in the summertime to keep their crops on schedule when we have those cooler night temperatures, for example. And I like to use this to think about if I was prioritizing which greenhouses I might want to make more energy efficient in my operation, and if some of those greenhouses are only used more seasonally, like in April, May, and June for a spring bedding plant crop. But I have other greenhouses that I'm using year round, then the year round greenhouse is the one that I would prioritize in terms of energy efficiency measures. And this came about, so I was talking about energy consumption and how that parsed out from cooling, heating, and electricity or lights. And this was actually modeled, so not real world data, but we'll talk about how you can collect real world data like this. And so indeed it kind of matches so that orange line is heating energy. And that matches that previous graph that I showed you where those winter months have higher energy consumption. And then it's no surprise, those are also the months that we need more lighting energy consumption as well. Um, to make up for the lack of sunlight or shorter days and cloudier days that we have that time of the year. And then you'll see this blue bar at the bottom is cooling energy. So that would be running the ventilation fans to cool a greenhouse. And maybe if we zoomed in, we'd see that should go down a tiny bit in January and February and December. But the main point here is that does not use anywhere near as much energy as heating and lighting.
And if you're a greenhouse that maybe, unlike one in New York, is maybe in Santa Barbara, California, the amount of heating degree days would be quite opposite. You might have a total of 1,000 heating degree days the whole year rather than one in a month. And then you might have an active cooling system, in which case you might have evaporative pad and fan, or in some cases, maybe if you're growing a crop like orchids, it needs to be really cool at certain periods. You might have active chilling. But yes, this is a great example of a greenhouse using vents and mostly just fans to move air through the greenhouse. And so we'll talk more about heating efficiency and lighting efficiency and how energy monitoring can be a way for you to understand, and benchmarking can be a way for you to understand what are the major contributors to your greenhouse where you are. So thanks, Neil, for diving into some of those systems like the greenhouse envelope, the ways heating and lighting might influence utility bills. And so this is an energy conservation pyramid that's developed by one of our GLASE Industry Advisory Board members, NSAVE, and it shows kind of the steps that a building owner or manager can take to work with partners and to consider how to reduce energy costs. Energy costs don't go down. Usually there's a utility rate case every few years that allows your utilities to ask for more money from the customers going forward to pay for different improvements to the infrastructure. So a business should always be thinking about how to reduce energy costs to either keep those things flat or to keep them from going up. So starting at the bottom, there are some steps you can take to analyze the energy you're using. That might be taking a peek at your utility bills and trending them over time in a spreadsheet, or it might be working with someone to do some energy audits or do energy benchmarking, which we'll talk about in a few slides. Energy conservation, that is something like taking what you currently have and just being better about how you use it. Energy efficiency, those are things like taking things out, replacing them, maybe installing new equipment. And then the top of the pyramid is when you might be playing with things like demand charges. If you're currently being charged for peak time periods versus off-peak, you might play with operating equipment during off-peak periods. And at the tip of the pyramid, you might incorporate renewable energy like solar to become more resilient, offset grid costs that might be rising, or just be able to have some environmental consciousness in your business portfolio you can put on the website. So there's different reasons to participate in different layers of this part of the pyramid, but we're going to talk about benchmarking as one of the steps at the bottom and very cost-effective step to work your way up. So I'm an energy engineer. I'm not a plant scientist. I appreciate the value of energy benchmarking applied to greenhouses, though, because they're a kind of like an industrial agricultural facility that's producing products that uses a lot of process equipment. And benchmarking is great for measuring and comparing energy performance of a facility over time. And that can be a great thing to apply to greenhouses as they're seeking to maintain profitability and overall just become more resilient and maybe expand and grow as a business. So benchmarking can be applied to all types of buildings. You can compare yourself to yourself year over year, or you can compare yourself to a group of peers if there's enough of you to compare against. And there's a few different units that are used. And so we've got some metrics at the bottom of the slide here that describe energy use intensity, which is a term used for all types of buildings. And the standard units that can be used for that are kilobTUs per square foot per year. And that adds together all the types of energy: gas, electricity, delivered fuels, wood, whatever you're using to make energy happen at the site. And then also understanding how much does that energy cost per the unit of production that you're having at your facility, whether that's number of plants, kilograms of product. The example here is dollars per kilogram. And then we mentioned greenhouse gas emissions, which again, not specific to greenhouses. It's referring to things like carbon emissions and things that create the greenhouse effect and increase the impact of global warming and climate change. We're talking here about kilograms of CO2 equivalent. That might be what you might see on a benchmarking report. So the purpose is to see how to save money over time by doing things like energy efficiency improvements or energy conservation.
And Gretchen, you've worked with a wide range of commercial buildings in terms of energy benchmarking. What would be some of the unique challenges in greenhouses versus office buildings or hospitals or something where there's probably thousands of them that have been benchmarked around the country?
I think the next slide will actually explain a couple of the challenges that I feel greenhouses experience. One of them is data collection. So if you're working with an office building, you might have fairly routine collection of data. Maybe there's an office manager that's collecting data on lots of buildings and paying the utility bills, and they've got some administrative person working
Mm,
on managing that data. But with greenhouses, there may not be an active tracking of data on energy consumption. The bills get paid, but there's not really a lot of administrative work checking out energy data. There may be crop production data that's being produced and tracked, but that's not maybe being linked to energy data. And then facility changes and characteristics. That's something that may be documented somewhere, but has to kind of gathered all together. So that's a challenge for any building, but I think that greenhouses are in some ways like mission critical facilities. They're not an office building where like there's going to be some downtime for you to come by. Anytime a benchmarking activity is happening with a greenhouse, there is something else critical happening. So you kind of have to get out of the way and get the data you need if you're working like me on a benchmarking report for a greenhouse. And if you are a greenhouse owner, you kind of just have to be as nimble and streamlined as you can to get the data to the person who's going to analyze it so that they can get their work done, because it can be without any good data, there's not going to be any good benchmarking report coming out. The second challenge, Neil, would be normalizing.
mhm.
So there are so many different types of greenhouses, right? And we kind of want to compare apples literally to apples. And so
Right, tomatoes to tomatoes, or so like
tomatoes to
if we're growing
tomatoes, yes.
if we're
And
growing a vegetable crop, it could be pounds or kilograms of tomatoes that we've produced. But
yeah, and is it even
mm,
fair to compare tomatoes to tomatoes when some tomatoes have different goals? Like maybe you're focused on size for one tomato, and maybe you're focused on taste and
good
other types of
point. The kind
qualities,
of
characteristics for. So I think in benchmarking, when you start for a greenhouse, compare to yourself. That's the very first thing to do. Get some years of data and compare, okay, have it gotten worse or better in these metrics over the years? And then normalize to what can make most sense for you. In our next couple slides, we'll talk about the New York State benchmarking program we've been running. And I think we've started to get enough greenhouses where you can compare folks to each other, but in some ways, greenhouse businesses are not interested in being included in a peer comparison pool. They may not want to be compared to others because they don't want their data shared. So that's another barrier. So maybe just comparing to yourself is the first place to start, and comparing against industry benchmarks is something that will be more possible over time. There are some, ag census reports and other types of CEA reports that have been published in the past few years that you can use, but that's definitely a challenge. So those are some steps of the energy benchmarking process after you initially gather the data, then you start to come up with some metrics that you can compare over time. And you generally will set one of those first benchmarks as a baseline to compare against going forward. And if you as a business change a lot, then maybe you set a new baseline. So yeah, next slide. After you start to compare against industry baselines, you might analyze ways to change those numbers. So let's go back to some of the things Neil was talking about. Maybe there's improvements to be made to the building envelope by maybe adding a thermal curtain. Maybe there are improvements to be made to the supplemental lighting system by retrofitting high pressure sodium to LED. And those sorts of things would be analyzed in a benchmarking report and suggested for implementation based off of how cost effective they might be, how quickly they'd pay you back, or maybe the greatest impact on energy savings. And then a good practice for energy benchmarking is to regularly do it and to regularly share it with stakeholders. So that might just be the people on your team, or that might be sharing it with greater industry groups so that we learn from it, like maybe sharing the results with GLASE, which is for our New York State benchmarking program, something that we are learning from. So let's talk about examples. So Neil, why don't you tell us a little bit about kind of the birth of this energy benchmarking program with NYSERDA? There's the greenhouse work that you've been doing to benchmark greenhouse operators since 2020.
Yeah, that's great. So New York State is blessed to have our Energy Research and Development Authority, NYSERDA, which helps the state kind of achieve the goals that you talked about in terms of greenhouse gas emissions. And one of the things that they've understood for a long time is that we want New York to have an increasing number of greenhouse businesses. That sector CEA is growing by about 15% annually in New York State. However, we want that industry to adopt best management practices in terms of energy, so that our state can continue to meet our overall energy use goals and carbon emission equivalent goals. And so NYSERDA has supported commercial energy audits for a long time of agricultural businesses. And then a few years ago, we got together with them to talk about how we could move beyond an audit to a benchmark and kind of more effectively collect data where, as you said, you could then compare to yourself over time and or alternatively compare to your peers to see how your energy use practices stack up. And our goal was always that if you saw kind of how your anonymous peers were doing and some of them are more energy efficient, that might make you think or realize that it could be cost effective for you to implement more efficient practices. And so maybe I can let you tell a little bit more about how the benchmark program works, Gretchen, but that was kind of the genesis of the idea.
Yeah, I will say it's unique in the country. Massachusetts does have the Mass Save program, which includes technical assistance services for greenhouses as well as energy efficiency rebates. I would say that the NYSERDA program is really unique with both the combination of this energy audit program and the energy benchmarking program. So let's talk about those. So we encourage anybody watching today, if you know a New York greenhouse, you are a New York greenhouse, the program is still open this year. We are pushing to have as many greenhouse benchmarks shared this year as possible, as the program will be coming to a close next year. So we encourage you to sign up today or share this with someone you know. It's a free service. We have been doing this for a few years and have produced dozens of reports, and our goal is to produce 80. So that would represent about, Neil, is that how many greenhouses of statistically proportionate 80
Yeah.
greenhouses out of New York's how many? Like 200?
So New York has 1,500 greenhouses or so total, but many of those are small family operations or seasonal operations. So our
Seasonal. Yeah.
target was about 200 of the largest greenhouses in the state, which are more than half an acre in size. So that's 80 would be quite good. I think market penetration for those
Yeah.
those 200 target facilities.
Yeah, and if you're listening and you're in a state that doesn't have this type of program, please find out if there's a way to have this program created. It would be great to see this sort of work in other states. So the way it works is there are third-party consultants that are part of the NYSERDA Flex Tech program. So they're qualified, energy engineers like NSAVE, who are able to go and visit your site and then benchmark things from energy use to production, as well as the way you grow, how often you're growing different crops, how you use your different spaces, what technologies you're using. And so those result in a benchmarking report that will also include the metrics we shared earlier. Next slide, Matt. It'll include the metrics we shared earlier. So something like, kilowatt hours per year, as well as things like kilowatt hours per kilogram of produced product. But it'll also include some report recommendations. So if you've got high heating use, like most greenhouses in New York, there are probably going to be some recommendations about if it's applicable to the greenhouse construction, installing an energy curtain. Maybe if it's a greenhouse that's covered with plastic film, maybe there's going to be an upgrade that can be done to that, or maybe something that can be applied to improve the insulative value of that, maybe some insulation of knee walls. Or there could be something like completely replacing a system, like replacing unit heaters with a condensing boiler system, or replacing high pressure sodium lighting with LED. So we included a quote from one of the participants in this program on this slide, and I think it speaks way more than I will to the value of it. And so it is very detailed, as they say, but it helps them improve operations in the bottom line. So folks responsible to investors care about the bottom line, and if it helps them improve energy use, it helps everyone. So we think that this has been a really valuable program for New York, and we hope that even if you don't have this program in your state, that you consider doing some energy benchmarking, working with a partner to find out some ways to save energy. And it will pay back quite quickly. Just the act of measuring your energy actually encourages a little bit of energy conservation. And then once you learn about ways to save, those things will pay back sometimes within a year. So some of these things can be very quickly paid back. And there are potential rebates from utilities or grants from government agencies for you to take advantage of for energy projects. Let's talk about audits and how they kind of complement benchmarking. You can do benchmarking without audits. Benchmarking can be done with just taking a look at utility bills and a spreadsheet of production data and a spreadsheet of square footage, and you can kind of make those calculations without ever going to the site. But an energy audit is what really will uncover the efficiency opportunities, because without seeing the site and knowing what's happening and what's changing, the benchmarks are just numbers, and you might not know why the number is high or why it's low. So an energy audit will usually include a quick site visit where a qualified energy professional, someone well-versed in agricultural buildings, will come and visit the site, ask about how you're running the building, ask about your equipment, how old it is, take a look at it, see how efficient it is, and they'll start to perform some energy analysis back at the office to estimate energy savings from different things like changing your set points, changing your lighting schedule, changing out equipment. And so they'll start to prioritize those for you either via cost savings or maybe payback period, which is something that's a return on investment calculation that takes into account how much the project costs and how much energy it'll save on your utility bill in a dollar value. So if it doesn't save too much energy on your utility bill and it costs quite a bit, it's not going to probably rise to the top. But some of the quick wins, some things that might cost very little to implement but have a pretty good result on the utility bill, those should be the ones to prioritize. And those often might be behavioral, something like changing a thermostat that currently is on a schedule and maybe implementing something that's got a sensor that's going to give more real-time feedback. Those things might be low cost. Things like controls and automation can often be a little lower cost than larger infrastructure upgrades like replacing heating systems and replacing envelopes. So New York also offers this energy audit program to complement the greenhouse benchmarking program. And it's open to more than greenhouses. So if you're watching this and you know someone in New York who runs an agricultural facility, pretty much anyone who is producing something on a farm can participate in this program. And again, a unique aspect of this is a qualified third-party flex tech consultant performs the energy audit. It's free of charge. And those who participate get both an energy audit report with all those efficiency project recommendations. And if they so choose, they can also get their greenhouse benchmarks added to that. So it can be like a one and done process if you want to do both of those. So Neil, let's talk a little bit about the sort of recommendations that come out of these audits and how often you see commercial greenhouse operators adopt these different recommendations and take advantage of the energy savings. What's realistic, you know?
Yeah, great. Yeah. So this was an audit example that came from one of our GLASE industrial members and Save. And looking at a facility, what they do is they list several of these different energy efficiency measures that are identified in that audit. Then the really helpful thing is they look into what would be the installation cost of actually adopting these measures. And then relative to the energy savings, they can calculate or estimate a typical payback period in years. So that can really help an operation prioritize which adoption measures make the most sense at this point. And from what I've seen from growers, if a measure has a 3-year payback period or less, it's much more likely to get adopted. 1 year is even better, or 2 years is even better. And then sometimes it also comes down to the capital cost or the upfront cost. So sometimes even if there's a 3-year payback period, if the current equipment hasn't reached the end of its usable life yet, the operation may decide that's still not a capital expense they're willing to outlay. But it kind of starts to sort of socialize the idea within the operation. So over the next couple years, as they're thinking about, okay, we have X amount to invest in the operation this year, now's the time that I want to add this equipment. So some of the low-hanging fruit that I've often seen operations adopt as we've gotten to higher heating fuel prices, or in some cases natural gas prices, installing those energy curtains have been really low-hanging fruit. And often those have kind of a secondary benefit that a lot of growers love is that they are also shade curtains. So these are retractable curtains. They can deploy them at night to trap in the heat and reduce their heating costs by about 40%. But they can also help on those really bright sunny days where it can get too warm in the greenhouse, and they can close those curtains and limit, say, 50% of the sunlight to help reach a more palatable temperature for their crops on those hot, sunny summer days or late spring days. So that's one that I've seen. I definitely have seen operations install heating systems that have higher efficiency. So they may be moved from old unit heaters to a condensing unit heater or boiler that can be a lot more energy efficient. And then we've seen many operations in New York State and around the U.S. start to adopt LED lighting systems too. And we could do a whole different presentation on the economics of that. But in places where electrical costs are high, so for example, in New York State, on Long Island and close to New York City, we have higher electricity costs. And so some of those operations are ones that I've seen have adopted LEDs, for example.
Yes, exactly. If your cost per kilowatt hour is high, these things will have a drastically different payback period. So thanks for chatting with me a little bit about the projects that folks might consider if they get an energy audit report. And the last few slides that we're going to talk about are, if you get an energy audit report or you get an energy benchmark report, maybe you might want to do some monitoring before you implement it, or after as well, to find out the impact. So let's talk a little bit about carbon metering and energy monitoring. So carbon metering is basically converting the amount of energy used into some form of greenhouse gas accounting, generally expressed as carbon dioxide equivalent, or CO2e. And so if you're currently looking at an energy audit report and you see some financial paybacks, but you want to understand, well, what's the actual maybe environmental payback of saving that energy, this can help a business understand the climate impact. So this might be for folks that have sustainability goals, or who are overall concerned about the contribution to, climate change of their business. This may not be the biggest priority for all, but it is something that if an organization wants to measure this, this is something that they can do. So it's generally something you pull from your electricity meters information, from your utility bills, from all your different energy sources. So we've got a picture of a electricity meter here, but the carbon accounting will add together, much like the energy use intensity, it'll add together all of your energy use together. Next slide. And so sometimes the sensors of a smart electrical meter might actually be measuring your energy consumption in real time, like every 15 minutes or so. That's generally more common in larger cities or in big investor-owned utilities. They might have implemented that. And so those will take the amount of energy used in that 15-minute moment and go and check what was the greenhouse gas content of the grid at that time. It's very intelligent systems taking a look at the mix of fuels on the grid at that time and saying, okay, for that kilowatt hour, that was a dirty kilowatt hour. And this next 15-minute period, it was a cleaner kilowatt hour. And it makes those sorts of calculations kind of behind the scenes. These are things that might be available from your utility, but may also be something that you might have to kind of track at a more general level, maybe not in a real-time way. So if you don't have a smart meter, you can still do carbon accounting. You just might be doing some kind of constant conversion factors for fossil fuel and coming up with some sort of average greenhouse gas content for your local electric grid, which is generally available from some sources like the Energy Information Administration. So that's if you want to do carbon metering, which may be a layer that folks might not need to do to make a business decision about energy efficiency. But the next slide talks about energy monitoring, which I do think is something that would be valuable for anyone to do to make a business decision about energy efficiency projects. So again, let's say you're holding an energy benchmarking report, or you're considering doing an energy audit, or you've just had one. Maybe going into the audit or going into getting that benchmarking report, you didn't monitor energy at the system level, i.e. you don't know how much energy the lighting system's using, but you know how much the greenhouse is using. Neil, how common is that?
At this point, not very common for an operation to parse out individual users of electricity. Primarily, it's just that one meter.
Yeah, and I think that depending on the greenhouse control system, there may be some energy monitoring offered, but it might be available only if you subscribe to a data package of some type. So you might have some data loggers that are already in your greenhouse that just sort of have to be turned on for access. But if you don't have a maybe sophisticated automation system, or you use a minimal amount of sensors, you can install energy monitors as a kind of layer of sensors that complement maybe your other climate sensors for temperature and humidity. So I just wanted to mention that if you take on energy benchmarking and you take on energy auditing, something that might come up is, hey, the lights are a good energy efficiency opportunity. You should replace those. But maybe you're not convinced they are the thing to replace. So maybe some system level data will be something that you can sort of analyze and share with the decision makers that will allow you to say, well, actually, yes, the system is consuming at, this period, this much. And if we extrapolate, we can understand that that's having this much of an effect on the bottom line. So it can be a tool to complement benchmarking and auditing. It might be something that an energy auditor can even install in your facility to complement the work that they're doing. Maybe they do a first site visit and install some energy monitors, and then they come back, gather the data from those, and then use those in their audit report. Generally, just a few weeks of data is enough to paint a picture of what's happening with a system. And if you want to, you can keep them installed kind of permanently and have some visualization of how things go seasonally. So to finish things up, I'll hand this to Neil to maybe share, what do you feel like are some kind of greatest tips for greenhouse benchmarking and monitoring for folks to take away as we finish our presentation today?
Thanks, Gretchen. Yeah, so overall, it's a worthy endeavor, and Gretchen showed that kind of pyramid in terms of adoption of energy efficiency practices, and the point being, if we understand our energy use more holistically, then we can make the most strategic decisions. So it will take time, effort, and expertise. It will require data collection and pulling in those utility bills. And if you want to make the process smoother for yourself, definitely consult experts, because they do this routinely, and so they can make it smoother. And the whole process can help to ensure data accuracy then at that point. I will point out, I guess we kind of discussed this, where we're not office buildings here, so the greenhouse industry does not have standardized performance metrics because of our diversity of crops, the different climates that we're in, and whether we're seasonal or year-round. Also, depending on size, sometimes larger size operations have more choices for energy efficiency measures than small size operations. So I think monitoring yourself and tracking against yourself over time can be a very viable method. And I do think over time we will be, through Glaze's efforts and other efforts, we'll be able to kind of holistically as an industry see more benchmarking coming out so that there will be larger pools of data where we can kind of compare ourselves to anonymized peers. If someone was requiring me, like if a state was requiring me to do benchmarking, which is not the case in New York State, I would make sure that any privacy concerns are addressed so that data is not being publicly shared and collected in a secure, anonymous way. And that we were clear about what are the performance indicators. So kind of that discussion with the apples to apples comparison. And in many cases, food production and greenhouse production is important for food security and the health and vitality of our landscape. So it is an essential service. So we need to make sure that this data is being used appropriately to help the industry improve over time and not to put undue policy on the industry. I guess those would be my personal opinions, starting to get a little more
No, I
personal
think that's a
here.
good
Yeah.
point. Like,
Hmm.
if I think to round this discussion out, the why would I participate in a benchmarking program with a third party? Why not just do it myself? I think that that is a good question for each business to consider for themselves and to think about if it is shared, how will it be used? Maybe in a sort of educational way or a way to further the industry is important, but to have it be used as a tool to um, affect greenhouses to make them do changes when they aren't, necessarily going to do them for any other reason if not for policy. That's maybe not what we'd like to see, but we do encourage the sharing of the data in a anonymized way because we, like academics, like researchers, we would love to be able to learn from the aggregate, not necessarily have to compare and contrast individual businesses. So